right, for this question, we need to understand the big idea is about total outcomes, which is total possible things that could happen. We've done a previous question about compound probability, where we had to know the total amount of different possible outcomes. This is similar to that. How many outcomes are there? Now, the strategy we're going to use is the same one we used in that previous question, make an organized list. We're going to list all of these outcomes, and then just count them up to see how many total outcomes there are. Okay, there are two things that are happening. There's a coin that's being flipped, and there's a spinner that we're going to spin. So, I'm also using draw a picture, as you can see. I drew a picture of the coin, a picture of the spinner. So let's talk about what could happen when you flip the coin. How many outcomes are there? Hopefully you got that there are two outcomes. It's either going to be heads or tails. Heads or tails. All right, what happens when we spin the spinner? How many outcomes? We've got three outcomes for the spinner. It's either going to be blue, red, or green. Blue, red, or green. Okay, let's make a list of all the things that could happen if you do both. So first, I'm going to start with just saying that the coin was heads up. So you could either get heads for the coin and then blue, or maybe the coin was heads, but you spun and got red. What would be next? Next, we're going to stick with heads on the coin, but maybe it was green. All right, what's the next thing going to be in our organized list? All right, so we've exhausted all of the coins being heads outcomes. There's nothing else that could happen. Either heads and then blue, heads and then red, or heads and then green. That's it. Now we're going to have to go to tails. Maybe the coin was tails, and maybe it was tails and blue for the spinner. Maybe it was tails on the coin and red for the spinner. Maybe it was tails on the coin and green for the spinner. Are there any other possible outcomes? And there are none. And so these are the total amount of outcomes. How many outcomes are there? 1, 2, 3, 4, 5, 6. 6 total outcomes, and we got that by making an organized list. Let me show you another strategy we could have done. We could have done a tree diagram. A tree diagram would work like this. First, you either got heads or tails when you flip the coin. And from heads, it was either blue, red, or green. Or from tails, it was either blue, red, or green. So now when you count the total amount of outcomes, you have to go to the final step on that tree diagram. So this one here represents heads and then blue. This represents heads and then red. This is heads and then green. This is tails and then blue, tails and then red, tails and then green. So we've got 1, 2, 3, 4, 5, 6. 6 total outcomes. So if you prefer the tree diagram instead of the make an organized list, then you could use that. It's pretty similar, pretty much the same thing, but it's just a way to show the total amount of outcomes. So then there could be a question like, what's the probability that you flip the coin and spin the spinner and you get tails and then green? And you can say, all right, well, how many of these are tails and then green? Only one of them is tails and then green. Out of how many altogether? Out of 6, you could say that probability is 1 out of 6. So you could use this strategy of getting the total outcomes to then help you with probability questions when it comes to compound probability. There you go.